let's learn about electron paramagnetic resonance spectroscopy part 2. First, let's learn about presentation of the spectrum. The APR spectrum can be represented by plotting intensity I against the strength of the applied field. APR spectra are commonly presented as derivative curves. The first derivative, that is, the slope of the absorption curve, is plotted against the strength of the magnetic field. It is easier to discern features in the derivative presentation if the absorption lines are broad. Two modes of presentation are easily interconverted, and the relationship between the two kinds of spectrum is given by absorption curves A and C, derivative curves B and D. A single absorption peak with no fine structure. So curve A is shown below. The curve A shows peak and no fine structure is seen in curve A. B is the derivative that corresponds to A. The derivative curve crosses the abscissa at the maximum in the absorption curve for the slope changes sign at the maximum. Curve B is shown below. Clearly we can see how the curve crosses the abscissa, and you can see how the slope changes sign at the maximum. C is the absorption counterpart of curve D. Shoulders in C never pass through a maximum, and curve C is also shown below. D is the derivative curve corresponds to C. Derivative peaks in D corresponding to these shoulders do not cross the abscissa, and curve D can be seen below. Here also you can see the peaks, all the peaks do not cross the abscissa. Number of peaks and shoulders in absorption curve can be determined from the number of minima, which is marked as asterisks in D, or maxima in the derivative curve. The APR spectrum of hydrogen atom. Beta has units of ergs per gas. Here in spectrum of hydrogen atom we see two peaks, and the space between the two peaks, it is given by A by G beta. The G value is measured at X, which is midway between the two solid circles corresponding to absorption peak maxima. The hyperfine splitting A by G beta is the separation between the solid circles in gas. The above figure shows positive value for A. The sign of A generally cannot be obtained directly from the spectrum. If A were negative, then Ms equal to minus half and Mi equal to minus half. Thank you.